In this example, I'm given this circuit topology and I'm being asked to compute the value of VDC that will make the branch current I naught 0. So this is a little bit unusual because typically for circuit analysis, or unusual for this course, because typically for circuit analysis, I'll give you all the different values, for example, the 15 ohms to 30, and I'll ask to compute power, compute the current, compute the voltage. So this is a little bit of a design twist. It tends a little bit more towards design than analysis. And the reason why is a lot of the times, like you have a circuit topology and I'm asking you to figure out the value of the voltage that will make this 0. That's why it's a little bit more of a design. So, of course, you can use typical circuit analysis technique to tackle these design challenges. For example, we can either use nodal analysis or mesh analysis, and we'll do it in the same way we do any circuit analysis. So I'm going to identify the essential nodes. This is one essential node, 2 and 3 and 4. So assuming that this is my reference, I'll end up writing 1, 2, 3 equations. So for node voltage analysis or nodal analysis, I'll end up basically writing 3 different equations. You might be tempted to say, well, this is just 23 above the reference, but don't forget that there's actually a 20 ohms in here. Similar in here, you might say, well, this is VDC above the reference, but there's also 25. So if there's a current going that way or this way, there will be a voltage drop or a voltage rise. Now here you might be, well, frankly speaking, because I'm targeting I0 to be 0, so the voltage drop across the 20 ohm will be 0. So I should know that this here should be 23 volts in here. It should be 23 volts because the I naught is 0. So technically you'll end up writing 2 nodal analysis equation, one in here and one in here. Maybe you would need the third one, but you already know that voltage in here. You should be able to do that. All right. Let's do the same type of things for mesh analysis. So for example, I can just assume that this is a mesh and I decided that the current should go in the same direction as that. Okay, and I called it I0 because it will be the same exactly value as I0 and it will be 0. And then I can say, well, this is my I1 and this is my I2, and I can write, well, for mesh analysis, I'll probably have to write 3 equations. I have 3 meshes. Yes, I do know this mesh in here, but I'll end up with a voltage that is missing, so I'll have to come up with a different equation to write it. So at the end of the day, I will have to write 3 mesh analysis equations. So probably I would go with the nodal analysis to solve the circuit, but because this example is part of mesh analysis, I'll do it with mesh analysis. I'll figure out what the value of VDC, and then I'll go back and I'll double check my answers with nodal analysis. All right, so by double checking, meaning I'll assume whatever the VDC value that we get, and then I'll compute what the value of I naught is. Okay, so let's get started. I will basically say, well, I0 is just simply 0 amp because that's what I wanted it to be, but I'll end up writing for that mesh I0 anyway. I'll write an equation, and I'll start from here, for example, and it will tell me that's 23 plus 20 I0, which is 20 times 0, which is 0, so I don't have to write that. And then, of course, I need negative 46 because the current I0 is hitting the negative first. And then I have plus 10, and that will be I0, which is 0, plus I1. And, well, plus because this one is going that way, and the I1 is going that way, so that must be a plus. And then plus 5, and then we have I0, which is 0, plus I2. Again, I0 and I2 are going in the same direction, that's why it's a plus, and that should be equal to 0. And then the way we do that now, we just do a little bit of algebra. We'll end up with 10 I1. I believe it will be plus 5 I2, and that should be equal to 23. And that's basically the first equation out of 3 because I have 3 unknowns, I1 and I2 and VDC. I know I0. Okay, so we continue. We write one for mesh I1. So for mesh I1, I'll start from here. Okay, so we'll do negative 46 plus 10 times I1, plus I0, which is 0, so I don't care about it, plus 15 I1, and I believe the I1 and I2 are in opposite direction. I1 is that way, I2 is that way, so that it has to be negative I2. I believe plus VDC, that's what I'm looking for, plus 25 I1 equals 0. Okay, with a little bit of algebra, I believe the I1 will be, it will be, like you can also see it in the diagram, that's what I see that, because the I1 will be 25 plus 10 plus 15. Okay, that's pretty much, that's 50 I1. Okay, so that's 50 I1. And the I2 is the only branch that shares this that way, so it's a negative 15. That's a pattern. After experience, you get you start basically writing these equations this way, and I believe that should be plus VDC. plus VDC, and that should be equal to 46. Okay, so let me just double check. The I1, we have that one, and this one. Of course, the VDC, we kept it in the same side, the negative 15, and 46 became on the other side. So yep, that's the second equation, okay, out of 3. So I need a third equation, and that third equation will come from the third mesh. Okay, so mesh I3, or I2 actually, I2. Okay, so for I2, I will just pretty much say, well, it will be 30 I2 plus 15 I2 minus I1 plus 5 I2 plus 0, or plus I0, so it's just plus I2. Okay, so, and that should be equal to 0. Okay, let me just write this right. Okay, so that's I2. Again, you can think about it this way. The I2 will be 15 and 5, that's 20, and 30, that's 50. Okay, so that will be 50 I2 and negative 15 I1 plus, let me just write this a little bit cleaner. Okay, so it will be negative 15 I1 plus 50 I2 equals 0, and that will be the third equation. And frankly speaking, the first and the last equations, this one in here and this one in here, should be able to give me the value of I1 and I2, and I just substitute them in here. So let me just do that. So the values would be, I believe I1, let me just write that, I1 will be exactly 6 amp, or 2 amps, sorry. Okay, it will be 2 amps, okay, and I2 will be 0.6 amps. So I'll take these two values, substitute them in this equation in here to get the value for VDC, and that will be VDC equals to, I believe it should be negative 45, I think, 45 volts. Let me double check and get back to you. Yep, negative 45 is correct. So we got that this should be negative 45 volts, okay? So we can do the same type of analysis. I can either analyze it knowing that this is 45 and just write nodal analysis equations just to figure out that I naught is 0, or I can just write nodal analysis equations and just figure out that 45. Either way is fine. I'll just take the analysis route. I'll just write nodal analysis equations, not knowing that this is I0. Okay, so I'll have to write an equation in here, an equation in here, an equation in here, and just solve them. And I'll figure out whether my answer is correct or not. So let me just do that in here. I'll just copy this image and put it down and work on that on a new image. Okay, so I will assume that this one here is V1, this one here is, I believe, V2, and this one here is V3, and I'm going to write equations. So the first one will be V1 minus 23 divided by 20. So I'm basically going through that, and this, okay? Plus, I believe it's V1 minus V2 divided by 5 plus, I believe V1 minus V3 divided by 30. That will be 0. Okay, so that's the first equation, and then we'll have to say, well, that's 1 divided by 20 plus 1 divided by 5 plus 1 divided by 30 V1 minus 1 divided by 5 V2 minus 1 divided by 30 V3, and that should be equal to 23 divided by 20. So that's the first equation in here, the first nodal equation. All right, we write it at the V2, which is right here, okay? So that will be V2 minus V1 divided by 5 plus V2 minus 46 divided by 10 plus V2 minus V3 divided by 15 equals 0. So that will be negative 1 divided by 5 V1 plus 1 divided by 10 plus, well, let me just do that here. I think I missed one. All right, so it's plus 1 divided by 5 plus 1 divided by 10 plus 1 divided by 15 V2 negative 1 divided by 15 V3 equals 4.6, because 46 divided by 10 is 46. So that's the second equation, and I need a third equation. Okay, the third equation comes from the third node, so that will be V3 minus V2 divided by 15 plus V3, well, negative 45 divided by 25. So in this case, I'm assuming that that's negative 45 because this is the answer I got from the mesh analysis, plus I believe it's V3 minus V1 divided by 30 for the resistor on the top equals 0. So we'll clean them up. That will be negative 1 divided by 30 V1, and I believe negative 1 divided by 15 V2 plus, I think it's 1 divided by 15 plus 1 divided by 25 plus 1 divided by 30 V3 equals negative 45 divided by 25, and that will be the third equation. So let me just solve these and figure out, hopefully, if my answer is correct, I should be able to get that V1 is 23. If V1 is 23, I know that there's no voltage drop in here and the I0 is 0. So let me just do that. And indeed, I do get the following numbers. I get V1 equals 23 volts, and I get that V2 is equals to 26 volts, and I get that V3 is equal to 5 volts. So what I got in here is this one here is 23 volts. So because this is 23 volts, and I know that there's a resistor between it and the actual reference in here, I know that the voltage drop across that 20 is 0. So that means this is 0 amps, and that's why this V1. Of course, you can double check the answers and just basically write KVL equations, or maybe figure out what the current is going from here and the current going from here, and then just sum them up to figure out, and you will get that I0 is equal to 0. So my answer was correct.